my wonderful students. Sorry about all that. Today we're going to be talking about how to write a quadratic equation in all three forms, of course, from a graph. So what we did last time, I gave you an equation and you had to get the other forms from the equation. Now what I'm going to do is I'm going to give you a graph and you should be able to get 2 out of the 3 forms from the graph, and then using what I've already told you from example 1, 2, and 3, you'll be able to find the third form. So you can always find factored form and vertex form from a graph. Okay, you cannot find standard form very easily from a graph. Okay, so what we're going to do, we can easily obtain vertex form and factored form from the graph, and then using either vertex form or factored form, you can then find standard form fairly easily. Okay, so this is our lovely graph that we're going to be using for example 4. You can either copy the graph down here, or you can copy down my graph. So I'll leave it up to you, but I'm going to go ahead and get started. I'm excited, you guys. This is fun stuff right here. Okay, looks like we're not frozen. Yes. Okay, let's get started. All right, so we have a graph. Okay, I've identified 3 points on our graph. So these 2 points smack the x-axis, which means they are x-intercepts, okay? And then this point is the minimum of the graph, which means it's a vertex point. Okay, so what we're going to do first, in the first example, we're going to start from vertex form. So I'm going to show you how to find vertex form and factored form from the graph. We're just going to start with vertex form first in this one. And then after that, using either vertex form or factored form, from the equation we can find standard form. So unfortunately, standard form kind of fails us just a smidge when we have a graph. But one good thing about standard form is it's easily obtained from vertex form or factored form. Okay, well, I'm going to get started. Guys, so again, vertex form is very helpful because if you know the vertex of your parabola, then you can write the equation pretty much. Okay, so if I'm looking here, the vertex of my parabola is at -1, -18. Okay, so remember when you write vertex form, you guys, the parts of the equations that you must have are the a, h, and k. Okay, well, I have the h and k, but which value am I missing? I'm missing the a value. So the a value, we can't get that from the graph, but I do know since the graph is facing upward, it's a happy graph, which means a is going to be positive. So I know a is positive, but I don't know what a is. Okay, so we're actually going to use parts of the graph to help us find the a value. Okay, so for now, I don't know a, so I have y equals a, I don't know. Okay, so I'm just going to write a. And then times x, remember, we must flip the sign on the h value. So since h is negative here in my equation, it will transform into a positive. So +1 squared. And then my k, it is what it is. So I'm just going to bring on down the -18. Okay, so the only piece that's missing in order for me to write my equation in vertex form is the a. Okay, so what we're going to do, we're going to use a different point on our graph that's not the vertex point because I already used that. We're going to use a different point on our graph to solve for the a value. Okay, which we have 2 really easy points right here to grab off of our graph. Technically, you guys, there are an infinite number of points on this parabola. Okay, but the 2 zeros are really easy to spot. And also something helpful, if you ever have a value that's 0, when you're solving, it'll make your life much easier. Okay, so these 2 points are good points to use. It doesn't matter which point I use. Okay, I could use -4, 0, or I could use 2, 0. Now, rule of thumb, you guys, the smaller your numbers, the easier your life is going to be when you're solving. I mean, I know you guys love to solve and everything, but remember, mathematicians like to be efficient. So I'm personally going to choose the smaller number point, which is the point with the 2. Okay, -4. 4 is a bigger number to deal with. So I know -4 is smaller than 2, but in general, 4 is a larger number. So it'll make my solving just a little bit more challenging. So I'm personally going to use this point. If you use the point -4, 0, you should get the same answer though. So it's kind of up to you and what you want to do. And I'd really like it, thank you, if it would stop freezing. But anyway, so I'm going to use the point 2, 0 right now. So the point I'm using is 2, 0. Okay, as now any point is the coordinate xy. So what I'm going to do, I'm only going to do this to help me solve for a. I know I've told you don't touch the x and y. I know I've told you guys that. But in order to find the a, I'm going to substitute in 2 for the x and 0 for the y, and that way I can solve for a. And then when I find a, I'll rewrite my equation like this where I don't touch the x and y. Okay, so we only touch the x and the y when we need to find a value in our equation, which in this case is the a value. Okay, so I'm going to replace x in my equation with 2 and y in my equation with 0, and then I only have one thing to solve for. I only have a. That's my only variable. So if I can cover all the other variables, it'll make it very easy to solve for a. Okay, so my y is going to transform into the y value of my coordinate, which is a 0. So we have 0 equals a times my x right here is going to transform into the x value of my point, which is the 2. Okay, so it's going to become a 2. Guys, so this is the point we're using to solve for a. And if you want to, you could write a little subtitle to organize yourself. This is the point. So after this step is when we're solving for a. So if you want to make a note that now we're solving for a, you can. So only this part is what we're doing to solve for a. Okay, and then I'll kind of block it off so you know this is the part where we're solving for a. But anyway, sorry, I know I got sidetracked. Anyway, so my x is going to transform into the x in my point, which is a 2. So we have 2 plus 1 squared minus 18. All right, if you guys see here now, the only thing I have in my equation to solve for is the a. So by substituting in this point, it allows me to solve for a. Now after this, I'm not going to touch the x and y. I'm just doing this to solve for a. All right, well, let's solve this thing for a. Okay, I'm going to deal with my parenthesis first, because remember, parentheses and exponents first. Okay, so we have 0 equals a times 2 plus 1 is 3. Okay, and now I'm going to deal with the square. Don't forget you square before you multiply. There's secretly multiplication here, but I'm going to square first before we multiply. Okay, so I have 0 equals a times 3 squared is 9 minus 18. All right, so now I just need to solve for a. So now it just turns into a pretty straightforward equation. Okay, so I need to get a by itself. Currently, this negative 18 is getting in the way. How do I bring negative 18 to the other side? I would add it on both sides. So negative 18 plus 18 cancels and turns to 0. 0 plus 18 is 18. Okay, so I'm left with 18 equals a times 9, or that's the same thing as 9a. All right, and then how do I bring 9 to the other side? Well, they are secretly multiplying, so the way I bring that bad boy over is by dividing by 9 on both sides. Which 9 divided by 9 will cancel and turn to 1. So I'm left with a equals 18 over 9, so a equals 2. Look at that. Okay, so all I did, I replaced x and y with a point on my graph to solve for a, and now that I know a, I can write my equation in vertex form. So now vertex form, I could extend this. My vertex form is y equals a, which is 2, times the rest of it, x plus 1 squared minus 18. And guess what, you guys? That's how you find vertex form. Guys, so you get the vertex point, and then you have to solve for a by using a point on your graph. Okay, so from here on out, everything's going to be very straightforward to find the other forms. Now, technically, if you wanted to, you could just convert to the other forms by doing it how we did yesterday. So, or not necessarily yesterday, but how we did in examples 1 through 3. Sorry, guys. But anyway, so I could just like manipulate the equation to get this thing into standard form and then factor it to get in factored form. I will say though, now that we know the a value, okay, and now that I have zeros on my graph, it's going to be really easy to find factored form. Okay, so first of all, to find factored form from the graph, if you guys remember, this is what factored form looks like. A times a parenthesis times a parenthesis. And don't forget, when you're in factored form, the way that you find your zeros is by flipping the signs. Okay, as in the true or it's true also if you reverse it. Sorry, my brain today. Okay, it's true if you reverse the situation. So if you know the zeros, to get into factored form, you simply just flip the sign and put x's in front. Okay, so guess what, you guys? We have zeros on our graph. Do you guys see that? So if I know the zeros, I can simply flip the signs to get them in a factored form. And guess what, you guys? The a value in factored form is the same a value in vertex form. So I can do factored form real fast after I know a. Okay, so currently my zeros are x equals -4 and x equals 2. Alright, so factored form will be y equals my a value, which a we know is 2 now because we found it earlier. So 2. I might run out of space. We'll have to see. Got to write small. Sorry, guys. Okay, and then all we do to get into factored form, got to write really small, we're going to put x's in each of your parentheses, and then you simply just flip the sign. So the opposite of -4 is +4. The opposite of +2 is -2. And guess what? You have it. You have factored form. Okay, so again, you can either flip the sign, or another way to think about it is to solve the equation and make one side of your equation equal to 0. Like, I could add the 4 on both sides to get x plus 4, and that would make this side 0. Or I could subtract the 2 on both sides to make that side 0 and make that x minus 2. Okay, so there you go. Factored form's done. Yes. So now the last form, standard form. Okay, standard form you cannot get in any way, shape, or form from your graph. I mean, you can, but it would take a lot of work. Okay, so I'm simply going to get to standard form by either simplifying down my vertex form or factored form. It doesn't really matter which way you do it. I'm actually going to show you both ways so you can decide which way you prefer better. Okay, the first way, I'm going to start from vertex form and get it to standard form. So this is pretty much like what we did in example 1 through 3. So if you want to try it on your own from here, you can and see if you get it right. So I'm going to start from vertex form first. So vertex to standard form first. Okay, then I'll show you how to do the same thing, but starting from factored form. Okay, so let's get started. So we have y equals 2 times x plus 1 squared minus 18. Okay, so if you guys recall, when we solved, I think it was example 3, if I'm not mistaken, but basically one of the examples we started from vertex form and you had to get to standard form. Okay, so if you guys remember, if you have something that is squared, what does it mean to square a number? It means to write it 2 times. Okay, do not say this is equal to x squared plus 1 squared. That's when the demon cats will get you. Okay, so I'm going to rewrite this twice. I'm going to say y equals 2 times x plus 1 times x plus 1. And then I'm going to bring on down the 18. Okay, so from here, I'm going to deal with my 2 parentheses. Which, how do you deal with 2 parentheses side by side? You do distribute. So I'm going to distribute these 2 first, then deal with the 2. Technically, you could distribute the 2, then distribute it again, but usually the demon cats get people when they try doing that. So it's not wrong if you do distribute the 2 first, only do it to one of the parentheses. Don't do it to both, or then you multiply by 4, so be careful. Okay, so I'm going to start with the first term and multiply it to each of these. Okay, so I'm going to bring everything on down. I got y equals 2, and I'm going to write what I get in here, and then minus 18. See if I can fit it in that parenthesis. I don't know. We'll have to see. Okay, so x times x gives me x squared. X times 1 is 1x, so plus 1x. All right, then I'm going to go the other way. Alright, so 1 times x is also 1x, and 1 times 1 is 1. Alright, so from here again, you could, from here, go ahead and distribute the 2. I personally like to simplify down my equation first, and then deal with the 2. But it's really up to you. It's not really a wrong way to do it. Alright, so looking here, my only 2 like terms in here are the 1x and the 1x. Okay, so I just need to combine these 2. I can leave the x squared and the 1 alone. So I'm going to bring on down the x squared. 1x plus 1x is a positive 2x. and I'm going to bring on down that 1. Okay, so now that I've simplified this down, and I'm going to try zooming in so you guys can see it a little better. Sorry, I should have thought about that from the start. I guess the demon cat's got me. Sorry, guys. But anyway, so now that I've simplified, and I'm going to try to focus it a little better. It looks like that's as good as it's going to get, you guys. Sorry. Okay. But anyway, so now that I've simplified down my parenthesis, now I'm going to distribute the 2 to every single number in my parenthesis. And then at the very end, I'll deal with the 18. Okay, so we have y equals 2 times x squared is 2x squared. 2 times 2x is 4x. And 2 times 1 is 2. And then I'm just going to bring on down that 18. Alright, the last step, you guys, is to combine like terms. What are the like terms in my equation? They are the 2 and the negative 18. I don't have any other x squareds or x's to combine. So I'm going to bring on down my 2x squared, my 4x, and then 2 minus 18 is negative 16. So there you go, you guys. That is standard form. Okay, so that's how you do it if you start from vertex form and go to standard form. I'm also really quickly going to show you how to start from factored form and get it to standard form. In my opinion, it's easier to start from factored form. But I just wanted to show you guys all your possibilities. Okay, so I'm going to kind of section this off real quickly. So now really quickly, I'm going to show you how to go from factored form. Factored, I think I just spelled that wrong. Yep, I totally did. Jeez, Miss Long. Why? Okay. Spelling is never my thing. That's why I just stick to math. Alright, so factored form to standard form, which if you see, I don't really have a lot of space. Look, I made it all fit in that line. Look at that. Nice. Okay, so now we're going to start from factored form, which our factored form was over here. Factored form was this. So we're going to start from here and get to standard form. And if we did it right, we should end up with the same equation. So let's see. I really hope we do. Otherwise, I'll have to redo this video, and that would make me very sad. Alright, so. Alright, we have factored form. So again, this is very similar to like this part of the vertex form problem. I'm going to distribute the 2 parentheses first, then deal with the 2. Okay, so that's kind of what I'm going to do real quickly. All right, so let's start distributing, you guys. Guys, so I'm going to start with the first term right here and distribute it to both of these. So first of all, I'm going to bring everything on down. I'm going to write what I get in my parenthesis. All right, so x times, I'm going to multiply x to both terms in this parenthesis. So x times x is x squared. X times negative 2 is negative 2x. 4 times x is positive 4x. And 4 times negative 2 is negative 8. Alright, now again, you can distribute the 2 right now and be done with distributing. Again, I like to simplify down my parenthesis first, then distribute. But again, you'll get the same answer, so it really doesn't matter. It's kind of whatever you prefer to do. Okay, so I'm going to first simplify down my parenthesis. Okay, what are the like terms in my parenthesis? Well, that would be the negative 2x and the 4x. So I need to combine those. Otherwise, I can bring down my x squared and my negative 8. So negative 2x plus 4x is positive 2x, and then I'm going to bring down my negative 8. All right, and then finally, the last thing I need to do is distribute, and then I'll be done, which if I did it right, I should end up with what we got earlier. So let's see. I don't know. Let's see. I really hope so, because again, I'll be very upset if I have to redo this. Okay, but anyways, let's get started. So 2, I'm going to distribute down here because it's a little busy up there. Doesn't really matter. All right, so 2 times x squared is 2x squared. So far, we're looking good. Yes, I got the first term. Yes, that's a thumbs up. There we go. Okay, then 2 times 2x is a 4x. Let's see. Still looking good. Look at that 4x. There we go. And then 2 times negative 8 is negative 16. Holy hot dog. Am I right? Of course I'm right. Well, there you go, you guys. So that is how you find vertex form and vertex form and factored form from the graph. And then again, you can choose to solve either way, starting from vertex form or factored form to get standard form. So unfortunately, standard form, it's very challenging to get from the graph. It would require a lot more work than this. So again, mathematicians are more efficient. This is the most efficient way to get these standard form equations. So there you go. Well, example 5 is pretty much the same thing. In example 5, we're going to start with factored form from the graph, which is going to be pretty similar to how we did vertex form. We're going to have to solve for the A like we did. But then vertex form will be really easy to find, and standard form you can get by either solving from vertex form or from factored form. So there you go. Well, excellent job as normal, you guys, and I can't wait to do example 5 with you.